All right, guys. You all got the work, the handouts?
Yeah.
How come I don't have the thing here? It's not right.
It's lit. Going to jail with that
Ah, I think I'm good now.
nigga. I'm really gonna kill that nigga.
All right.
Cause that's gonna be mad scary.
So we're going to be talking more about what the graphs of functions can tell us.
Yo,
Khalil. We're going to be talking about different things that the graphs of functions can tell us. And then we're like, what we call these things. We talked a little bit the last time you were here about minimum and maximum values. You guys remember that?
nope.
All right. Well, then it's a good thing we're going to review a little bit here with this one. So here is a function that they graphed, right? Now notice they're not telling us what the equation is. They're just saying y is equal to f of x. That's just generic. That means like we don't know what the rule is here, okay? But if you have a picture of it, we could figure out some things about it. They're saying that this function here is graphed over this interval. -7 is less than or equal to x, which is less than or equal to +7. That just means that we're only looking at this piece where the x goes from -7 to +7. Okay? So we don't care what happens over here. We don't care what happens after that. It says find the maximum and minimum values of the function. Well, the maximum is the tallest point. What's the tallest point here? What's the value of y right there? Seven, I think.
-1.
And the x is -1. Good. Right? So the xy coordinates at that point would be -1, 7, right? And we're going to write that like this. So we're going to say the maximum value is f of -1 is equal to 7. You could just write like this, y is equal to 7. Oh wait, no, you know what I can't do? Normally you could do that, but it says state the values of x where they occur as well. This way it gives both the x and the y, okay? So somebody tell me what's the minimum value? Minimum would be the lowest point.
Wait, hold on. What are we supposed to write that? Hey? You're supposed to write that right there?
The max, put max is f of -1 equals 7. So where's the lowest point on the graph?
Oh, over. Yep.
Good. That's your minimum right there. What's the value of x right there? -5. And what's the value of y? -1. Good.
So it's going to be f of -1 equals -5.
The other way around. The x is the -5. So f of -5 equals -1. Right? The thing in the parentheses is always your x value. The x is the -5. The y is the -1. So this is your max. And this is your min. So yeah, f of -5 is equal to -1. Right? Your x and y coordinates. Just remember the thing in the parentheses is always your x. Marcus, you got it?
Oh, yeah.
Says, okay. Right, just remember the minimum value is the lowest point on the graph here, in terms of the y-axis, up and down, and the maximum is the highest point. Okay? So the next question says, what is the y-intercept of the function? Anybody know what the y-intercept is here?
What that say right there? F -5, -1?
Equals -1.
This one here? Or that? F of -5 equals -1. Which I got right from here, from the xy coordinates at that point, right? The x is -5, the y was -1. What's the y-intercept here? Where does the graph cross the y-axis? That's what it means by y-intercept. Huh? What's the value of y?
1, 2, So,
6.
Oh.
Right? That's your y-intercept. So we're going to say y is equal to 6. If you remember this equation, did we do that this semester so far? No? You guys have probably seen this before, no? This is called slope-intercept form. The b is the y-intercept. So in this case, it would be something plus b. This is actually not, this is only for a straight line. But when we get to straight lines, you're going to see that b is the y-intercept. Just it's where the graph crosses the y-axis, okay? It says, explain why a function cannot have more than one y-intercept. So why can't that graph cross the y-axis in more than one place?
what?
Why can't there be more than one y-intercept? Like, why can't
Because
the
that's
graph...
the only line on the point.
Right, but they're saying for any other function, for any function you can think of, why can't you have it where it crosses the y-axis in more than one place?
So it could be a function of
You said that?
Yeah.
Yes. Sabian said it exactly right. Because remember we said in order to see if something's a function, it has to pass that test, the vertical line test.
Yeah,
If it crossed this more than once, that would mean it would fail the vertical line test. Let's say you had a function that was like this, right? Well, right there, how many times does that cross the y-axis? 1, 2, 3 times even, right? Then it wouldn't be a function. Like, it's possible to have a graph of something like that, but it wouldn't be called a function. It would be called a relation, okay? Which wouldn't really deal with, we're talking about functions now. So explain why a function cannot have more than one y-intercept, say, because then it would fail the vertical line test and it wouldn't be a function. So far, so good? Let me get rid of all the stuff here now. Can I erase?
Oh.
You okay? Can I erase this? Am I racist?
Wait, what's
I'm
that
racist.
blue squiggly line you got on the graph? Like, what that represents?
The blue one, that was just to show if it has more than one y-intercept, it wouldn't be a function anymore. That's just something I made up. That's not a function because it doesn't pass the vertical line test. Remember I said, like, to see if something's a function, you move like a pencil across it. And if the graph hits it in more than one place anywhere, that's not a function. So this blue line is not a function. And in order to be a function, it has to, like, never cross back on itself. So. Okay? Can I erase?
Please.
Please. This is such a nice boy. Let me just scroll up a little bit. Son of a sailor. This is still the same function we're talking about, right? Now let me just reduce it. I'm having trouble fitting it all in here. Okay, good enough. So, give the x-intercepts of the function. How many places does the graph cross the x-axis?
Twice.
Twice, good. What are the values of x there? Right, that's, what's the value of x here? Negative 1, negative 4 and what? Negative 6, good. So I'm going to say x is equal to negative 4, x is equal to negative 6. These are also known as the function zeros, because at each place there, the y value is 0, right? So the xy coordinates of that first point would be negative 6, 0, and for this point it would be negative 4, 0. So if they ask you what are the zeros of this function, they're looking for the x-intercepts, okay? Zeros equals x-intercepts.
Wait. That's for C?
That's for C, yeah.
That's by X.
For C, you just have to write down, these are the two x-intercepts. X equals negative 4 and x equals negative 6.
Because they both touch the x-axis.
Right, that's where the graph crosses the x-axis. You got it, good.
Alright.
So now it says, would you characterize the function as increasing or decreasing on the domain interval negative 5 is less than or equal to x, which is less than or equal to 1. So in other words, between negative 5 and negative 1. let me just get rid of this so we can start from scratch again. So we're looking at where x is negative 5. 1, 2, 3, 4, 5. This is where x is negative 5, and we're going up to where x is negative 1. So we're just looking at this piece of the graph right here. Okay? We're not looking anywhere else right now for this question. It says, would you characterize the graph as increasing or decreasing now?
Increasing.
Increasing, because it's going up from left to right. Good. Explain your choice. Just say because it's going up from left to right. Now it says one additional interval over which the function is increasing and one over which it is decreasing. So apart from this one here, can you give me another interval, another piece where it's only increasing over?
Wait.
Let me just.
Why is it increasing?
Just because the line is going up from left to right. You see how this is going uphill? Khalil, if you were walking, along this line, you'd be going uphill, right?
Yeah.
That's why it's increasing.
No,
Okay?
so I said explain. Like I see it though. Yeah.
Oh, okay.
I just didn't know why I was like.
Just think of yourself, if you were walking along there from left to right, you'd be going uphill, that means it's increasing.
Alright.
If you're going downhill, it would be decreasing, okay? So give me another piece that's not this piece where it's increasing over, from where to where?
To the
From 2 to what?
Four.
You could say 4 or 5 even. I mean, you don't have to take the whole piece, you could take a little piece, any piece of it. So that's from 2 to 4, or 2 to 5. I thought. Either one, 2 to 4 or 2 to 5. It's only going up during that piece, right? So now we have to write, whenever you see interval, you have to write it like this, right? So we're going to say the left side is the 2. 2 is less than or equal to x, which is less than or equal to 5 or 4. You can use either one. Now let's look at intervals. Give me one interval over which it's only decreasing.
5 to
7.
Yeah, that'll work. You see this piece here, it's only going downhill, right? So 5 is less than or equal to x, which is less than or equal to 7. All right? So notice, when they say where it's increasing, it doesn't mean the maximum, right? Sometimes people get confused between the two. The other thing is, actually, they don't talk about this yet, but I might as well talk about this now. There's another thing they talk about, which is where is the function positive or negative? Can I get rid of this now?
Please.
Oh, such a nice boy. When they talk about positive or negative, they're talking about the y values. Are most of the y values here positive or negative? Huh? No. The y values.
Is it equal?
Huh?
Is it equal?
positive.
It's positive.
Most of them are positive. Look, this is all positive. The values of y here are all positive. They're above the x-axis, right?
Oh, I see what you're saying.
Right? It's all above the x-axis. So the only part that's negative is that little chunk right there.
I see what you're saying.
This
So
here
what
is the
you're telling me
negative
is-
part.
What you telling me, Mr. Kia?
They didn't ask this, but they're going to ask this, I think, on the other side or tomorrow. Okay, so I just figured I'd mention it. There's some of the things they talk about are maximum and minimum values, increasing and decreasing, and also positive and negative. Okay,
So wait, positive is above the line. negative
above
is
the
below.
x-axis,
Yeah.
negative is below the x-axis. Yeah.
I thought it was like different, like a while ago. Like one part was negative and the other part
That we
was
did in this
something
class?
like,
Oh.
just regular algebra. I can't recall.
I mean, I'm trying to think of what you were talking. I don't even know.
Like it would be different, like both of the times might be negative. I mean positive.
Are you thinking of this
Something
thing?
like that.
Are you thinking of the different quadrants where like
Yeah. Quadrant.
the X and the Y in this quadrant, they're both
I was
positive?
like 1, 2, 3, 4 or something.
Yeah.
I remember.
So in order for a point to be here, you'd have to have a positive X and a positive Y.
Yeah.
In order to be here, you'd have to have a negative X
Yeah.
and a
Exactly.
positive Y. Okay. And down here would have to be negative and negative, and here would be positive and negative.
Yeah.
That's what you're talking
Yeah.
about. Okay. That's like even more basic
I
stuff.
remember as soon as you said quadrant.
Good. All right, let's get back to actually what they're asking here. The following points are known as turning points. Let me just get rid of this thing.
No, I need to go out for lunch.
A turning point. A turning point is just what it sounds like. It's a place where the graph turns around. So this would be a turning point because it's going from decreasing to up here it's increasing, right? This is a turning point as well because now it's going from increasing to decreasing. So all of these are turning points here. It's where the graph changes direction or turns around. Okay? Workers, you listening?
I see it too.
So it doesn't matter if it's a maximum or a minimum, it's considered a turning point.
They're not
So-
asking this neither?
Well, no, they are asking this.
Oh.
So here they're giving you 4 turning points. 1, 2, I guess the 4 that I just picked here. It says for each one, you're going to state whether it's a relative minimum or a relative maximum. And tomorrow we'll talk more about what they mean by relative, okay? So is this one, you think that's a relative minimum or a relative maximum?
Relative minimum.
Minimum, yeah, because it's like the bottom of the valley. -1 to 7. You think that's a relative minimum or maximum?
Max.
Maximum, yeah. This one here,
Relative max.
this one,
And the other one's relative max also.
this one is, but not this one.
Oh, yeah.
That's a min,
2 is
and that's a
relative
max.
minimum.
You got it.
I thought it was max because there's both positive.
No, the negative and positive doesn't have anything to do with this, because you could have like this, Khalil, look, I could have, if the graph, let's say, went like this would be the maximum,
Yeah.
but the y value would be a negative because it doesn't reaches there. So you can't just go by the y values, okay? It's possible to have a maximum that does have a negative if it's below there, okay? All right, so we had min, max, I think, right? And just let me mention, since we're here, this point here is called a relative maximum. This point here, since it's the biggest maximum, and we're going to learn this tomorrow, is called an absolute maximum, like absolute vodka.
Yeah.
Absolute means it's like the highest high or the lowest low. You could have other ones that don't reach it, so this would be a relative max, this is the absolute max. What do you think this is, a relative minimum or absolute minimum?
Absolute.
Yeah, because it's the lowest low. And this would be a relative min. I think tomorrow's lesson, they talk about this a little bit more. Is that it? We just got through the worksheet?
No.
Back.
Oh, okay, I was gonna say, it just seemed like it was fast.
I was about to say yeah, but I wouldn't have passed for that.
But you're having fun with this, aren't you? This isn't bad, right?
I mean, you know what?
Well, okay, fun is a strong word.
Yeah. I mean, I'm having,
You're
I'm
not
having
hating.
a good time. Like,
Okay, there you go, there we go.
It's fun, like.
Good, that works for me.
Yeah.
So, actually, let's see, I can probably bring this up a little bit. No, I'll leave it this size. No, you know what, for the people that, if they're watching on the video, maybe they won't be able to see it. So this is a piecewise function. Did we talk about piecewise functions before?
Hey, Mr. Keegan, you be putting this on YouTube?
I'm going to.
Alright, well. you told me
I have a
couple
bunch of them I haven't put on yet that I have to, because I have to like edit it a little bit,
times. Yeah.
but they are going to be.
I would that shit on Facebook. Got anybody that needs help with that?
Mr. Keegan, can I get water?
Yes, you can get water. As soon as I get to the top here. Okay. So here's our function, right? A piecewise function is just a function that has more than one rule. So you see this has two rules. It has one rule is x plus 3. It has another rule of 6 take away 2x. So your question should be, well, how do I know which rule to use, right?
Yeah.
Which rule you use depends on the value of x. You see the top rule says if x is less than or equal to 1, you use the top rule. If the x is greater than or equal to 1, you can use the bottom rule. So let's just fill this stuff in here. You'll see you'll see how it works.
Wait, what?
This is called a piecewise function. It has more than one rule, okay? And which rule you use depends on your input value. If the x value is less than or equal to 1, you can use the top rule, the x plus 3. If x is larger than or equal to 1, then you're going to use the bottom rule. You'll see.
That makes no sense.
So if x is -4, which rule do I go to?
Probably the bottom.
Nope.
Yeah.
That says if x is greater than or equal to 1. This is -4.
To the top.
So it's
you
the top
use-
one.
look, from going from 0 to down, 0 to 1, 2, 3, 4, you're gonna use the top one, and then for the rest, you're gonna use the.
Actually,
bottom
from 1.
one. So 0 don't count?
Because 0 is still less than or equal to 1.
Oh, okay.
1 is where it changes, actually. You'll see. And actually, how I do these is
Why did you draw the line under the 1?
because 1, you see, you have to use that. 1 actually gets used twice, believe it or not.
Okay.
Actually, this is unusual. Usually they would have like one of these be like, doesn't have the equal, so you know where it changes. But you'll see. Look at the top here, I'm just going to write the rule next to it here. So when the x's are smaller than or equal to 1, you got to use the x plus 3. When they get above 1, you got to use the bottom one, right?
I was thinking of the one.
So this is going to be, what's -4 plus 3?
Yeah, a 9.
What's -4 plus 3?
-1.
All right, so the first point is going to be -4, comma, -1. Then what's -3 plus 3?
How do this by myself?
Yeah. I'm just going to do a couple. You all should do it by yourself, actually.
I don't think so.
Speedy Gonzalez. Huh? What? Oh. You want a new paper or you just want to erase?
You said if there's more than one, it's gonna be the top.
No. If it's more than 1, it's the bottom.
Which
See,
one is more
that's
than?
that's less
The
than
bottom
one.
princess.
That's the reason. Remember, left, less than. Right? Left, less than.
It's not fast.
All right, guys, do this. Do it in. And then plot it.
So wait, mister,
So
so
I'm
one,
going down by
You're just using the x value each time. Huh?
x equals 3.
Mr.
Oh, which
Can I
one?
get a
Really?
Like, you see what you put next to the thing?
Mr. King.
Over here?
Yeah.
That's the y value. I added a little column
No,
here.
on the other side, on the left hand side.
This is your, oh, this.
Yeah.
That's to show you which rule to use, right?
X
So-
equals
If, as long, until you get to 1, you're gonna use the rule x plus 3. Oh, it kind of looks weird, I guess. Is that what you're saying? You couldn't read it?
3. Nah, X plus 3. I thought
I got that from there.
Oh.
And then this is the thing I got from there. It's just that if you write it here, you don't have to keep looking at that thing. It just makes it easier.
So when I get here,
Mr. King.
When
I
you
gotta
get
do
here-
all these until I get here.
Yeah, when you get here, you're actually gonna use both rules. First, you're gonna put it in there, then you put it in there. But then once you get past the 1, you're only using this rule.
Oh.
So it'd be 6 minus 2 times 2, etc.
Wait, which number you use both rows? You use
1.
1.
Yeah, and this one, like I said, this is a weird example. Usually, one of these wouldn't have the equal, so it would show you like where to stop. But I think what happens here is at 1, it gives you the same value for both, so it probably doesn't matter.
Mr. King.
Yep.
Can you come here, please? Two times 4 is 8. 6 minus 8 is
Let me see your graph. Piecewise functions by the way, piecewise functions, here's what they look like. They kind of look like
I have to
two
grab
straight
it.
lines that
Yeah,
meet.
like, nigga had to second guess it, like, I don't know.
Guys, piecewise functions, they look like two straight lines that meet at a weird angle, almost like the hands of a clock. What's
They're not. Nah, man, I'd rather. I mean, then again, that's gonna be up your ass, like, you feel me? But then again, like, it's fucked up when you're part too, like.
Anyone got white out?
Yeah, I got some white out. Why? Why? Because I'm white, you figure I'm white out. That's base. That's mad racist.
Can I go to the bathroom?
I don't ask you if you have a cafe or layout.
I don't know how to graph it.
That's what the
What are you talking about? X and Y. -4, -1.
Okay.
I never had it before.
Hey. Nigga say.
Oh, you never had white before?
I never had it before.
That's the key.
Yeah.
Nigga say, life sounds like.
All right, give me one
How
second.
you graph when it's 0 and 3 lanes?
So 0 means you don't go left to the right, you just stay there, and then you go up 3,
That's what I'm saying.
right?
So,
The X is 0?
Yeah, like I could picture. You over the back flyer like.
So -3, and then you just stay right on that.
Yeah. Yeah.
where?
This is the beat. That would be so much crying, so much comforting. Like,
I think I broke the white
yeah,
out.
Khalil.
like, nigga said,
Khalil, what's your graph look like?
it's looking like yours, bullshit.
Just trying to fix
I'm
it.
dead.
You broke it? I have the old kind of white. You want
Yeah,
that?
yeah, you feel me?
That's a great
I don't know.
We'll figure it out, don't worry.
Yo, like.
No,
Can you like be quiet for like 5 minutes and don't talk and shut the
Thank you.
You want your Paris?
Khalil,
I am actually.
Khalil,
I don't think you like David Cole.
Of course.
Khalil. Come on, work, don't talk.
Shut up.
Thanks, bro. I appreciate that. But I don't think this is going to
Does
get
it look like I care?
saying
I'm
we'll
just
get
saying,
no
like,
time soon.
Some don't like that.
Alright, Khalil, can you please?
Khalil been doing this. Like, I'm doing this now.
They say he broke it, I'm sorry.
I didn't bring it. You made it worse.
Well, I might be able to
So,
fix it.
nice.
Wait, hold on. What you just got for the last one?
Exactly.
4, -2?
Oh,
Yeah, I wrote the wrong
thought
thing.
You got 8. I'm about to say.
Yeah, but I did it wrong. So, 2, 2, then 3, 0, and then 4, -2.
Why it goes down this ugly?
This is what a piecewise function looks like. It's two lines that meet at some sort of angle.
Ugly ass line.
Now here's the thing. Put arrows at the end, okay? Oh, you know what? For this one, you don't have to put arrows because we're only going.
It's just status.
No, for the interval -4 to +4. Yeah, we don't need to put arrows at the end. Let me just get rid of the arrows. We're just going to where they said -4 to +4. -4 to 1, 2, 3, 4. So we're going to get rid of the ends. We don't care about that. We're only looking at this piece of this thing, right? Now, the only other thing you got to do to get full credit on this is you got to write the rules next to the part that it corresponds to. So for this part, you're going to write that. That's all right. F of x is equal to x plus 3. This piece was the bottom one. F of x equals 6 minus 2x. and that would get all your credit. So does everybody have this shape like this?
Yeah.
That's what whenever you see something like that, that's two straight lines that meet at a weird angle, you say to yourself, oh, that must have been one of those piecewise functions. It's got two different rules. Hi.
For Marcus?
Marcus, he just went to the bathroom.
Okay.
He'll be back in a minute.
Okay, oh wait.
Okay.
Thanks.
All right, well, we got a couple things to answer here on the bottom, though, right? State the zeros of this function. Remember, we just learned what are the zeros? What are they looking for? Where what's equal to 0?
X and Y.
One of them, not both. The y is equal to 0. Basically, where it crosses the x-axis. So what's the value of y, x right there? -3, and this is +3. So x equals 3, and x equals -3. What's the y-intercept? Y equals what? Where's the y-intercept? Huh?
And it crosses down.
Where it crosses the y-axis? Here's where it crosses.
3.
Did you see somebody out there?
Huh?
Did you see somebody out there just now?
Lady.
She wants to see you or something? Okay. So you're just gonna write y is equal to 3, right? That's where it crosses the y-axis.
I got you. Don't worry, 69. I got you. What was it, 61?
Oh, shit.
Exactly.
Alright, but who got the highest score in this class? So,
No.
me, did you? No. Alright, so.
I got you.
You take.
You don't. Then it says, give an interval over which the function is increasing and give one over which it's decreasing. So,
What number is that right there? Wow.
this one here?
Yeah.
Y equals 3. That's the y-intercept.
You got the 3.
Huh?
Like, you feel me? Like,
You got the 3.
wow.
Okay.
Like,
Right? That's the y-intercept, and these are the two x-intercepts. Actually, right, they're all 3. One's a negative. So it says, state an interval over which it's increasing. Well, it's increasing any piece of this from here to here. You can use the whole thing or any piece of it. It's decreasing from here to here. So just give an x, and you have to write it like x, like whatever. Some number is less than or equal to x, which is less than or equal to some number. You got to write it like an interval like that. Okay? No, what's that? Here, what's the value of x here?
Why?
So that goes there. What's the value of x here? 0. Yeah, you just did it. Wow, that was so much work. Oh. I have to rest now. All right. Khalil,
That's the D, right?
Hushabye.
That's the D, right?
Huh?
That's the D, right? D
That would
increasing.
have posted me in my.
That's for D, yeah.
D increasing or decreasing?
That would be increasing, because that's from here to here. It's going up. So, I mean, you can use whatever you want, okay?
You would have paid my medical bill.
Then it says, yo. Then it says, give the coordinates of the one turning point and classify it as either a relative maximum or relative minimum. There's only one turning point here, right?
From 4 to -2.
Say again?
From 4 to can't go.
No, what's the turning point here? Where does the line change directions? That's what a turning point is. Yeah, right here, right?
4 to -2.
No, it's 1, 4, right? One, 4. Now, is that a relative maximum or a relative minimum?
Maximum.
Yeah, it's the high point, so that's a max. All right, use your graph to find all solutions to the equation f of x equals 2. In other words, they're saying all the places where the output is 2, positive 2. Well, I can't erase everything. Let me just erase some of the stuff. just trying to get rid of some of the extraneous stuff here. All right, so it said, where f of x is, where the output is 2. So the output is the y, right? The input is always the x, the output's the y. So where does y equal positive 2? You got it. I'm doing letter E, I think it is. No, F, I'm sorry, F. This is where y is equal to 2, right? Any point on here is where y is equal to 2. So how many places does the graph cross that purple line? And what's the value of, what do we have to give it, x? Yeah. X is -1 and x is positive 2.
What's D?
D was one of these things.
Turn it back this way.
Hold on. F of -1 equals 2,
103 touched
and F of 2 equals 2. Those are the two places where the output is equal to positive 2, right?
That's F?
That was F. So the last thing, state the interval in which this function is positive. What part of the graph here is the graph positive? From what number to what number?
From 1, -1,
-1 to?
+2.
Good, perfect. Let's see if I can get a color. Oh, let me use that yellow color.
Wait, so that's what number F?
This was letter F.
That's not F.
Yeah.
Okay.
This, the last one, G, is what we're doing now.
Why you skip D and E?
I didn't. You were talking.
It's all your fault. I'm blaming this all on you.
So where I put the yellow, that's where the graph is positive. Oh, I'm sorry, wait a minute. Positive is above the x-axis. We're not talking about this line. We're talking about the x-axis. So it's, we both screwed up.
I didn't mess up.
Oh, well, I did,
Okay.
right? Because I forgot that the purple line is where y is equal to 2. For positive, it's just above the x-axis. So what's the x value here?
-3.
-3. And what's the value here? X? Is it positive 3?
I mean, 3.
So basically, it's going to be like this, except that's a positive 3, right? -3 is less than or equal to x, which is less than or equal to positive 3. That's the interval over which the graph is positive, right? Because down here it's negative, it's below the x-axis.